given a curve, the normal line to that curve at a point A, comma B is a line that's perpendicular to the tangent line that also passes through the point A, comma B. To do an example of a normal line, I want to do problem 46 off page 173, which graphs this curve, known as the Cissoid of Diocles. The instructions for 46, way down at the bottom of the page. Find equations for the tangent and normal lines to the Cissoid of Diocles, y squared times 2 minus x equals x cubed at the point 1, comma 1. And then at the top of the next column of the page, they show us the curve with the tangent line and then that line perpendicular to it. So tangent and normal. So from here on out, anytime we hear the word normal, we're going to think perpendicular. So I'm looking for the equation of the tangent line and the equation of the normal line. Two different lines that make a right angle with each other. Well, I know how to start. I'm going to start by taking a derivative of this equation implicitly, treating y as a function on x. That's going to give me the slope of my tangent line. We'll find the tangent line, then we'll see if we can find the equation of that perpendicular line going through the same point. All right, so I need to take the derivative of the left-hand side. Y squared times 2 minus x, and then the right-hand side 2x cubed. The derivative of the left-hand side, what I need to know is first is this is y squared times another function. I have to use the product rule. The first times the derivative of the second plus the second times the derivative of the first. On the right-hand side, the derivative of x cubed is 3x squared. My job now is to get the dy dx by itself. Well, let's add y squared to both sides to get rid of this piece. Then I'm just left with 2 times 2 minus x dy dx equal to 3x squared plus y squared. And I'll do a little division, and I'll have an expression for the derivative. So dy dx is equal to 3x squared plus y squared all over 4 minus 2x after I distribute. So that's what's going to give me the slope of my tangent line. Dy dx evaluated at the point 1, comma 1. All right, on the top, that would give me a 3 plus 1 is 4, and on the bottom, I would have a 4 minus 2 is 2. I get a slope of 2. So when I'm thinking about my tangent line, the slope is going to be 2, and the ordered pair I have to pass through is 1, comma 1. I can use point slope. I'll find that equation, no problem. Let's think about that normal line. The line's still going to pass through the point 1, comma 1, but I need a slope. I need a slope for a line perpendicular to that one. And I remember that perpendicular lines have slopes that are opposite reciprocals. So the slope for my normal line, which I'm going to call m, and this is a little symbol for perpendicular. We usually read this as m perp, and that's minus 1 over 2, opposite reciprocals. Now all I have to do is find the equations of those two lines. There's the equation of my tangent line. Now let's find the equation of our normal line. And that should be a point 1, comma 1 sitting right there. All right, I need to distribute. That'll be y minus 1 equals minus 1/2 x plus 1/2. I need to add 1. So my normal line will have equation y equals minus 1/2 x plus 3 over 2. All right, so this was my tangent line, and this was my normal line. And if I look at your author's pictures, The normal line has a negative slope and a y-intercept that's supposed to be at 1.5. That looks pretty good. And then my tangent line should have a y-intercept at -1, and that's looking pretty good too. Just in case you don't believe me, below this video I have linked a GeoGebra graph of all three things together.